When you think of an asteroid impact, what's the first thing that comes to mind? The blinding flash? The earth-shattering shockwave? A continent-sized tsunami? It turns out that's not the whole story. The real danger isn't just the moment of impact, it's the years of darkness that could follow. So forget the Hollywood fireball for a second. Picture a world where the sun is a ghost in the sky. This is the story of how a major asteroid impact could threaten our world, not just with a bang, but with a long, cold whimper. This is the truth about the cascade of problems that could begin long after the initial blast. Let's be clear. The disaster movie playbook gets a few things right. A mountain of rock screaming through the sky, glowing white hot from atmospheric friction would be terrifying. If it's big enough, say a kilometer across, it would hit with the force of millions of nuclear bombs. The immediate effects are hard to even imagine. A thermal pulse could spark wildfires across entire continents. A blast wave would flatten everything for hundreds of kilometers. The impact could trigger earthquakes that would dwarf anything in recorded history. And if it hits an ocean, it could generate a mega tsunami that scours coastlines clean. But this is just the opening act. As horrifying as it is, the initial devastation is mostly regional. The true planet-altering danger is what happens next. It's a chain reaction of global disasters that starts in the seconds after impact and unfolds over years. In the moments after impact, the asteroid doesn't just punch a hole in the ground. It vaporizes trillions of tons of rock and launches it straight into the stratosphere. This isn't just dust. It's a superheated mix of pulverized rock and aerosols. Think of it like the most violent volcanic eruption possible, but instead of one mountain, it's a city-sized chunk of the Earth's crust being blasted into the upper atmosphere. The finest particles are light enough to get swept up by the jet streams. Within hours, this veil of debris starts to spread, wrapping the entire globe in a dusty shroud. For people on the ground, the sky would turn a strange, dusky red. Before dimming dramatically, the sun, the engine of life on our planet, would start to fade. This isn't just a theory, it's physics, and it would be the beginning of a very different world. Welcome to year one of the impact winter. The sun isn't gone, but it's drastically dimmed. Globally, the amount of sunlight reaching the surface could plummet. Without the sun's warmth, temperatures would start to fall. Recent models suggest that after a medium-sized impact, average global temperatures could drop by as much as 4 degrees Celsius, pushing the planet into a sudden and severe cold spell. This isn't just a cold snap, it's a fundamental break in the planet's climate. The weakened sunlight disrupts the water cycle, meaning less evaporation and as a result, a lot less rain. Some studies predict precipitation could drop by 15 to 60% in major agricultural regions. Life on Earth is built on a simple formula. Sunlight feeds plants, which anchor almost every food chain. But in this new, darker world, that formula is broken. Photosynthesis, the process that powers life itself, would start to slow down dramatically on land and in the oceans. For humanity, this would be the start of a global food crisis. As the impact winter takes hold, the dominoes fall faster. With photosynthesis hobbled, the foundation of the global food web starts to crumble. On land, forests and grasslands would wither. The animals that depend on them would face starvation, and the predators that hunt them would soon follow. For humanity, the situation would be dire. Our entire agricultural system is built on predictable seasons and reliable sunlight. In an impact winter, that system is broken. Some models show that crop yields in the world's most important bread baskets could drop by 20 to 30% or more. Grain stores would only last so long, and the idea of a reliable harvest would become a memory. As if the cold and famine weren't enough, another threat could emerge. Some models predict that the same chemical reactions in the stratosphere blocking the sun could also damage the ozone layer. This would mean that the faint sunlight getting through is now laced with higher levels of UV radiation, making the surface even more hostile to life. Interestingly, there might be a strange twist in the ocean. The same iron-rich dust that dims the sun could fertilize parts of the ocean, leading to huge blooms of certain kinds of plankton. But it's a cruel irony. It would be nowhere near enough to make up for the catastrophic loss of food on land, where most of us live.
A decade after the impact, the world would be a very different place. It would be colder, darker, and drier. Society as we know it would be pushed to the brink.
Global supply chains, the intricate web that sustains modern life, would have likely shattered in the first year. Survivors would be forced into small, isolated groups, struggling for resources in a hostile world. While some of the more extreme predictions, like rivers being globally clogged for years, are speculative, the long-term disruption would be immense. Studies of past major impacts show that while the climate does eventually recover, the short-term shock is what causes mass extinctions. The real danger of an asteroid was never just the explosion, it was the systematic, multi-year demolition of our planet's life support system. This scenario is terrifying, but it is not our destiny. For the first time in the 4.5 billion year history of this planet, one species, us, can see the threat coming and actually do something about it. We are not the dinosaurs. Organizations like NASA's Planetary Defense Coordination Office are actively finding and tracking near-Earth objects, and we've proven we can act. In 2022, the DART mission successfully slammed a spacecraft into the asteroid moonlet Dimorphos, altering its orbit. It was a huge moment, proving that hitting an asteroid to nudge it off course is a real, viable strategy. And the work continues. The European Space Agency's Hera mission is now on its way to study the DART impact up close, and it successfully flew by Mars in March 2025 to keep it on course for its 2026 arrival. Plus, NASA's upcoming NEO Surveyor, an infrared space telescope planned for launch around 2027, is designed specifically to hunt for those potentially hazardous asteroids, which will dramatically speed up our ability to find any threats. Together with observatories on the ground, we're building a real planetary defense network. The challenge is huge, and what we know about these cosmic threats is always changing. If you want to learn more about the science of survival and the missions protecting our world, make sure to subscribe and ring that notification bell. It's a story we all need to be a part of. It's a stark reminder of how vulnerable we are in a cosmic shooting gallery. But it's also a testament to our own ingenuity. Our ability to understand this threat, to look into the vastness of space, and to prepare a defense is our greatest hope. The dinosaurs couldn't look up. We can, and we must.